Hello, boys and girls. Welcome to the Dow Academy Online Learning. We look forward to seeing you all back in class. But for now, stay home, stay safe. And remember to always wash your hands with soap for at least 20 seconds. Let's begin.
Good morning. I hope you are safe. We are looking at Form 4 Physics, waves, general wave properties. General wave properties. We want to know what is a wave, types of waves, and how do we show them. So, what is a wave? What is a wave? When we talk of waves, we are saying this is transfer of energy without matter particles being transferred. What are we saying? We are saying when we have a wave, there is a disturbance which happens to the matter particles and energy is transferred from there, going out, without the matter particles moving, but energy being transferred or transmitted. That becomes a wave. We are very familiar with waves. People are talk of water waves, light, and the like. All those are disturbances in which energy is moving, right? We are going to illustrate waves. Let's say you have tied a rope to a pole there, then you wiggle the rope. You wiggle the rope, pull it up like that. It creates this wave motion. Same thing when we have water in a pool and you disturb the water at some point. You see some waves spreading out. You have water in a pool and you disturb the water at some point. You see some rings of ripples spreading out. Those are all waves. The water is not moving, but the energy in the water is moving. Okay, types of waves. We have got two types of waves: transverse waves and longitudinal waves. Don't confuse types and examples of waves. We have got types. Types, transverse waves, longitudinal waves. So we are going to start by looking at transverse waves. Then in the next lesson, we'll look at longitudinal waves. What are transverse waves? In transverse waves, we are saying the vibrations or the oscillations of the particles, the disturbed particles that you disturbed, the way they move, is at right angles or 90 degrees to the wave direction. When you disturb the matter particles, they move at right angles to the wave. So if this is the disturbed particles going up and the wave is like that, they meet at 90 degrees. This is what we have here. The wave is going in that direction, but the matter particles which have been disturbed are moving up and down, up and down, up and down. They are not going that way. They are moving up and down as the wave is going that way, such that they meet at 90 degrees. We've got components of a transverse wave as shown here. We identify a crest, the upper part of a wave, a trough, these lower parts of a wave. We identify a wavelength, the distance between two successive waves, and we've got amplitude, the height of a wave. All those things are shown on a transverse wave. So we've got wave terms, which I was mentioning there: crest, trough, amplitude, and a wavelength. So what are examples of waves or examples of transverse waves? Remember, trans is a type. Then examples, we have ripples on water, which we usually call water waves, and all the electromagnetic waves, for example, light. Your homework, you are going to list now the other examples of electromagnetic waves. There are about 6 more remaining, which I want you to put down as your homework. Examples of electromagnetic waves. Stay well, stay safe. Thank you.